Continuing with vectors, here are some vector properties. Let A, B, and C be vectors, and let C and D be scalars. Then we can add A plus B or B plus A. We know vector addition is commutative. Vector addition is also associative. I can add A to the sum of B plus C, or I can add A plus B and then add that sum to C. The additive identity for vectors is the zero vector. That seems reasonable because the additive identity for numbers is 0. The additive inverse for vectors is the negative of the vector, so A plus negative A is the 0 vector. I can distribute a scalar to a sum of two vectors, C times A plus C times vector B. If I have two scalars added together times vector A, I can also distribute. And if I have two scalars multiplied together times vector A, I can use the associative property to multiply C times D first and then multiply by vector A, or take C and multiply by the product of the scalar product dA. And 1 times vector A is still vector A. So these are some properties of vectors. The next thing on the list is standard basis vectors. Some books may call these standard unit vectors. A unit vector has length 1. So these are going to be standard vectors that have length 1. So if we draw our xy axes, we have special vectors. We have vector I, and if you have a unit vector, typically it's denoted with a little triangular hat. Vector I is given by the vector 1, 0. Vector J is given by the vector 0, 1. If we were in 3 dimensions, we would also have vector K, which would, well actually if you're in 3 dimensions, I would be 1, 0, 0, J would be 0, 1, 0, and we would have vector K that is 0, 0, 1. So graphing these, we get these vectors right here, 1 unit long. If I make them position vectors from the origin, this is vector I, this is vector J. So I can take that information and I can rewrite any vector in terms of these standard unit vectors or standard basis vectors. So I can take the vector 3, 4, and I could write this as 3i plus 4j. It's a linear combination of unit vectors. And anytime you see this, you know this is vector notation. This is the same thing as 3 times the vector 1, 0 plus 4 times the vector 0, 1. So you get 3, 0 plus 0, 4. When you combine them component-wise, you do get 3, 4. So we can always write vectors with this triangular notation we've been using, or in terms of a linear combination of our standard unit vectors. So I can find A plus B if A equals 3i plus 2j and B equals 2i minus 4j. What I prefer to do is always change that linear combination of standard basis vectors into our normal notation. So A is 3, 2 if I write it like this, and B is 2, negative 4. So if I want A plus B, I just add up the components. That's 3 plus 2 and 2 minus 4, which gives me 5, negative 2. Okay, and a unit vector, as we said a few minutes ago, is a vector of length 1. So if I'm given a non-zero vector A, when I say non-zero, it's not equal to the unit vector, not equal to the 0 vector, then the unit vector in the direction of A is A with a little hat. Again, that's a notation for unit vector. That equals vector A divided by the magnitude of vector A. So if we have a unit vector in the same direction as A, we need the A there to tell us the direction. We are dividing by the magnitude because we want the magnitude to be 1. So here's an example. Find the unit vector in the direction of the vector A equal 5i plus 3j. So A equals 5, 3. I need the unit vector in the same direction. So the first thing I need to find is the magnitude of A. Remember, I can write magnitude of A this way or with double double lines. So I take the first component and I square it, plus the last component and I square it. So I get 25 plus 9, which is the square root of 34. So the magnitude of A is 34. If I want the unit vector in the direction of A, I write that as A hat equals vector A over the magnitude of A. So that is 5, 3 over square root of 34. Sometimes you'll see it written as 1 over root 34 times 5, 3. Sometimes you'll see it's where it's distributed, 5 over root 34, comma, 3 over root 34. And sometimes we might even rationalize this. Multiply the top and the bottom by the square root of 34 on each piece. There we go.